Welcome everybody. Today we are going to be dividing polynomials. This is very much like factoring polynomials. It's a way of breaking down a polynomial into simpler parts. We're going to use a method called synthetic division, which is a way to break down polynomials when we're dividing by a linear factor or a divisor that's linear. Divisor is something you divide something by, right? So yeah, we'll have a couple of terms we'll be using today that you probably haven't heard in a while. If you have a number and you divide it by something, this is called the dividend. This is called the divisor. And then whatever you get here, that is called the quotient. Okay, so the result of division is a quotient. All right, so we're going to use this method when our divisors are linear and they look like x minus something. C is any constant number. Okay, so how this works, I'm going to kind of skip this box here and just jump into an example. You can look at that later. Here we have an example. We need to divide x to the fourth minus 10x squared minus 2x plus 3 by x plus 3. So we're going to break this down by dividing it by x plus 3. So what you do is you take, this is your divisor, this is your dividend. You take the constant in the divisor and you change its sign. Okay, so it was a positive 3, it becomes a negative 3 here, and you put it out here. And then you draw this big L shape, and you put the coefficients of your dividend here. We had, for our first coefficient was 1. Ooh, where's this 0 come from? Well, we're missing an x to the third here, so you do have to put that in. I might just write these in for the time being so you can see where these came from. Okay, and then the negative 10 was for x squared, the negative 2 was for the x, and then 3 was just the constant, all right? So that's where those came from. I'm going to go ahead and erase those because that'll confuse us for the next step, but that's where those came from. All right, so now what we do is I'm just going to show you how this works. I'm not necessarily going to tell you why it works, but this is the how. It's actually based on long division, which we're not learning in here. You might learn about it if you take pre-calculus, but this is based on polynomial long division. Okay, so you first bring down your first coefficient here. And then what you do is you multiply 1 times negative 3, and that's what goes here. Then you add these up, and you get negative 3. Then you just repeat that same pattern. This number times this number. That gives us 9, positive 9. Then you add these up, you get negative 1. This number times this number. You get 3 up here. Add these up. You get positive 1. 1 times negative 3 is negative 3. Add those up, we get 0. Okay, I know it's probably been a while since you've done long division, but at the very end of a long division problem is your remainder. We're only going to learn about polynomials that have a remainder of 0 in here. Again, if you might study polynomials that don't have a remainder 0 in another class. And then what these are the coefficients of the resulting polynomial, starting with the constant, and then this is the coefficient of the linear term, meaning in our case the x term, and then the quadratic term, or x squared, and the cubic term, and then we're just going up for there if we had more. So what this means then is this polynomial here. So what this represents then is the polynomial 1x to the third, and I don't have to write the 1, and then minus 3x squared, minus 1x, but I don't have to write the 1, so minus x, and then plus 1, because it's positive. So that's the quotient here. So what does this mean for us in terms of what we're doing in this unit? Well, basically what I did here is I took the original polynomial, x to the fourth minus 10x squared minus 2x plus 3, and I divided out the x plus 3. So I could think of this polynomial as x plus 3 times the quotient here. It's a form of factoring. So I factored out an x plus 3. If I was to multiply this back together, it would equal this. Okay, so that's this is our answer there. We're just being asked for the quotient, but just kind of to let you know where we're headed, this is why we're doing this, so we can factor out linear factors out of polynomials. All right, let me do one more, and then I'll have you guys do one. So what I like to do is just draw out the big L first. And then remember this number, we take the opposite of that and put that out front. Always the opposite sign. And now we'll list out our coefficients. This has a coefficient of 1, coefficient of 5. Then we're missing a cubed term. We're missing the cubic term. So we put in a 0. You do have to put in those placeholders. We call those placeholders. And then this has a coefficient of 1, right? So we put a 1 here. Coefficient of negative 2. And then we have the negative 35 here. All right. So you bring this one down first. Then you take this number, multiply it by that. You get negative 5. Add these up. You get 0. 0 times negative 5 is 0. And then 0 plus 0 is 0. 0 times negative 5 is 0. A lot of zeros in this one. 1 plus 0, 1. 1 times negative 5 is negative 5. Add those up, we get negative 7. Negative 7 times negative 5 is positive 35. Add these up, we get 0. And remember, this is our remainder. Sometimes I just like to put a big R next to it. This is our constant in our the polynomial that is our quotient. This is the constant. This is the linear term. There's b's here, so I'm going to put a b. And then this would be like our b squared term, or b to the third, and b to the fourth. Notice we have some zeros this time. That means I'm not going to have those terms. So what this results in is 1b to the fourth, or just b to the fourth. I don't have to write those down because they're just zeros. They have coefficients of 0. And then I have a plus 1b, which I can just write as b, and then I have a minus 7. So this is the answer. That is the result of this polynomial being divided by b plus 5. All right, you guys go ahead and do the one right over here. Let's try something different going over this problem that I asked you guys to do. I'm going to show it, but it's going to be at a faster speed. But if you want to slow down the video and see what I'm doing, you can do that, and you can pause, of course. All right, so there is my final answer of a to the fourth minus 10a cubed plus 7. Just a reminder, that is the answer, but what I've done is basically divided this polynomial by this, so I could think of this original polynomial as factoring to a minus 1 times a to the fourth minus 10a to the third plus 7. So just keep that in mind as we go forward. We might be doing that in a couple lessons.